So this is Notes 13, page 8. Now here we're going to talk about a special case that comes up sometimes when you're adding rational expressions, and if you recognize this scenario, you save yourself a lot of time and trouble. It has to do with opposite factors and denominators. So if we find opposite factors in denominators, before building the common denominator, we're going to see that we can factor out a -1, and that will actually shrink the common denominator. So just consider the fraction -2/3. And here the negative is right level with the fraction bar, and you would read this as the opposite of 2/3. Now, when you have a negative in front of a fraction, you can put the negative like in front of the bar, or you can actually put the negative in the numerator and read this as -2/3. And that's the same as -2/3 because a negative divided by a positive is negative. You can also put the negative of a fraction in the denominator because a positive divided by negative is still negative. So this is still -2/3. Now, it can go in any one of those three places. Typically, we put it here and here because we don't like negatives in the denominator. It just messes with getting a common denominator. So, essentially, what we want to look at is a problem that's equivalent to this. 1/-7 plus 5/7. We don't need to build the common denominator as -7 times 7 because those are different factors, and make the common denominator -49. We don't need to do that. We just realize these are opposite factors, and we can just move the negative up to the numerator, or we can think of multiplying top and bottom by -1, which is what we'll do when we have algebraic expressions. And then we have -1/7 plus 5/7. Voila, we already have a common denominator. That's just 4/7. So, very equivalent problem here. 5/2x minus 3 plus 2x plus 2 all over 3 minus 2x. We want to add them. We need a common denominator. You cannot factor these denominators, so you scoop them in parentheses. Voila, they're now factors. But you want to recognize these are opposite factors. So remember, when you flip numbers around a minus sign, you just get opposites. So I'm not going to need to multiply these two together and build a big common denominator. What I'm going to do, I'm going to factor a -1 out of this denominator. So -1 times what gives me +3? That'll be -3, and I'm just going to put that in the back. -1 times what will give me -2x? That'd be +2x. Then I'm going to remember, hey, the negative in a fraction can be in the denominator, or you can just move it up to the numerator. Now, when I move the -1 factor up to the numerator, I got to realize it's a factor of the entire numerator, so I definitely need parentheses here. But when I do that, look at the denominators. They're already common. I don't have to get a common denominator. They are alike. So I'm ready to add the numerators. So I just add the numerators. I will distribute that negative. So that'd be 5 minus 2x minus 2. And this gives me -2x plus 3 over 2x minus 3. And maybe you don't recognize what that is. Maybe if you wrote it this way, 3 minus 2x, that's what the numerator is, over 2x minus 3, you recognize these are opposite factors, and they cancel to a -1. So this big expression right here, no matter what you plug in for x, you could plug in a half for x. It'll turn out to be -1. You can plug in 7 for x. It'll turn out to be -1. You can plug in 1,000,000 for x. It'll turn out to be -1. There's only one number you can plug in for x here where this will not turn out to be -1, and that's that value that makes the denominator 0. We can't let x be 3/2. So remember, all I did to get that is I said, oh, don't let 2x minus 3 be 0. So 2x should not be 3. I added 3 to both sides. X should not be 3/2. So as long as you don't plug in 3/2, you plug in any other number into this nasty expression, it's going to be -1. These two are equivalent. So let's try this with a slightly larger problem. Here, I want to add these. I build the LCD from prime factors of the denominators, and these denominators don't look prime. I need to factor the denominators. That's what I'm going to do first. So this first denominator should recognize that as a difference of 2 squares, but the x squared's in the back, so you have to factor it 1 minus x, 1 plus x. Got to have the x's in the back. This one could be the plus, this one could be the minus. That doesn't matter, but you can't flip that around to x minus 1, x plus 1. All right. Plus 1 over. All right, no GCF here. Looks like it comes from FOIL. It's definitely x and x. And let's see. It's definitely 4 and 1. It's plus 4 minus 1. Okay, so at this point in time, you can list your restrictions if you're asked to do that. Don't let your denominator be 0. So if x was 1, that would make this denominator 0. If x was -1, that would make the denominator 0. If x was -4, that would make the denominator 0. And then if x is 1, but we've already listed that, so we don't need to list it again. So those would be the restrictions. Now we're ready to think about the LCD. There are really 4 different factors. And with 4 different factors, the LCD would be the product of all 4. You would just multiply all 4 together and it would be a mess. But it doesn't have to be that bad. Notice these are opposite factors. So what I'm going to do is I'm going to factor a -1 out of one of these. Not both. Then you'll have opposite factors again. I prefer the way x minus 1 looks, so I'm going to factor -1 out of this. So I'm going to do that right here. I'm going to factor out a -1 just from this factor. Okay, so -1 times what gives me +1? That would be -1. -1 times what gives me -x? That'd be +x. And then for this factor, I just like it better as x plus 1. This is the new version of this denominator. And now when I build my LCD, I only have 3 factors, because what I'm going to do is I'm going to move the negative up to the numerator. And then I'm going to say, all right, my LCD, I see x minus 1 factors, so I have to have that in my LCD. I see x plus 1 factors, and I see an x plus 4 factor. So I have to multiply all the different factors together to build the LCD. If the same factor shows up in 2 different denominators, take it in the LCD with the largest exponent that you see, and the largest exponent we see on the x minus 1 is the 1. So there it is. That's my LCD over here. So remember, I'm moving the -1 up to this numerator, so that's a -x over x minus 1 times x plus 1. That's what this fraction is. Here's the denominator I have. Here's the denominator I desire. Which factor is it missing? The x plus 4. So I multiply top and bottom by x plus 4. Plus, okay, the second fraction. This is what it looks like now. Here's the factors that it has in the denominator. Here's the factors that I need. Which factor is it missing? The x plus 1. So I multiply that top and bottom by x plus 1. And now, this is where it's really, really efficient to remember. We never add denominators. We just add the numerators and put them over the common denominator. I do not want to waste my time multiplying these denominators out. It's just going to be over x minus 1 times x plus 1 times x plus 4. But the numerators I do add. So I want to know if there are like terms. So in the numerator, I am going to distribute that negative x. So that's going to be negative x times x, which is negative x squared. Negative x times 4, which is minus 4x. Then that's a plus, and you can distribute the positive. It doesn't change anything. It's going to be plus x plus 1. And so I do have some like terms. That's negative x squared minus 3x plus 1 all over x minus 1, x plus 1 times x plus 4. And you would try to reduce this to reduce this. That's when you look to see if you could factor the numerator of your answer. And if you think about that, there's no way you can factor that. So that's it. You're done. And just remember, this equality holds. This original expression is equivalent to this one, which is a little bit easier. At least it's all one term. But they're equivalent for any value of x except 1, negative 1, and negative 4. And this little trick's only going to happen occasionally, but it's handy to see when you have opposite factors in denominators.